Welcome, Year 10 students, to another exciting episode of Mathematics. Today we're going to be looking at exercise 4H, which is our final exercise for chapter 4. And we're going to be finding lines of best fit, which are also sometimes called trend lines. But we're not going to be doing it in a technical way. We're just going to be using our eye to get an approximate fit. So let's talk about some of the information that we need to have an understanding of. We've talked about what bivariate data is. That's when you've got two numbers that are linked together. It could be height and weight or something like that. And when the bivariate data is linked together with a strong linear correlation, in other words, when you put all of the crosses, you might end up with something like this. So all of the points look like they're in a straight line. That's called having a strong linear correlation. And when something like that occurs, you can draw in a trend line or a line of best fit, as I just did. Now, when you draw that line in, what we're going to do is this. So let me just redraw another one. We're going to have a few dots. Here's my points. When I draw in my line of best fit, it's really important that when you're drawing it in, you notice that there are a few dots above my green line and a few dots below it. I'm trying to get a balance. And the distance between each of those points needs to be taken into account. Now, there is a precise way that you can do this, but we are doing this just by looking at it and getting a bit of a gut feel, which means your answer might be a little bit different to the person next to you. That's okay. That's fine. We're looking at it, and as long as it is within an acceptable range, we'll be fine with it. Now, the other thing that we need to remember is a formula to find the equation of a line. Now, one of the formulas that we've used in the past is y minus y1 equals mx minus x1. We could also shortcut our technique by using this formula, and I sometimes have referred to it as a bit of a super formula because we're doing two things at once. But if you remember seeing this one, you could also use this formula as a one-step way of getting to the answer instead of doing it over two steps. Now, when you've got the line of best fit, we can use that to interpolate or extrapolate. Now, the word interpolation and extrapolation are words you probably haven't heard of before. Interpolation is when you're going to predict outcomes based on within your data range, and extrapolation is predicting what might happen outside your data range, and we'll look at that in more detail as we do an example. So let's get into our first example. Here it is. Consider the variables x and y and the corresponding bivariate data. So if they come in pairs. First point that we're going to plot is 1, 1. So let's label our axes first. We notice that we're going up to 7 and up to 5. So the x-axis we can go up in 1s, the y-axis we can go up in 1s, and everything will fit. And we plot the point 1, 1. The next point will be 2, 2. So go out 2, up 2. The next one, 3, 2. Out 3, up 2. The next one, 4, 3. Out 4, up 3. The next one, 5, 4. Out 5, up 4. 6, 4. Out 6, up 4. 7, 5. Out 7, up 5. So there is my data that has been plotted on my scatter plot. Now it looks as though it's got a bit of a linear trend. You can see that it's going uphill and that it's, close to a straight line, not quite. Now, part B says, is there a positive, negative, or no correlation between x and y? Now, if it looks like it might be heading uphill in a fairly much a straight line, it's positive. If it was heading downhill in a straight line, it would be negative. And if we couldn't see a line and there were just points all over the place, then we'd say there was no correlation. So this definitely has a positive correlation because it looks as though everything is heading upwards as we go left to right on the graph. Next part says to fit a line of best fit by eye. Now, you're going to need a ruler to do this. Without a ruler, it's very difficult. And so what we do is we bring in a ruler and we place it in such a position that when we draw our line of best fit in, that you can see that I have a few points above my red line and I have a few points below my red line. I even have some that are on the red line, which means my line of best fit or my trend line is pretty close to where I want it to be. Now, if we use the trend line, here it says use your line of best fit to estimate the value of y when x equals 3.5. So we come out here to x, on the x-axis, we come out to 3.5 and we head upwards to our line and then we project across to the y-axis and we say, where is that point there on the y-axis? Now, this is a bit of a guess. I'm going to say it's about 2.7. You might argue it's 2.6 or you might argue it's 2.65. It's an estimate. So I'm saying it's about 2.7. The next part says to find the y value when x is 0. Well, x is 0 here. So we go up. What's the y value there? Well, I'm going to guess that the y value there is around about 0.3 because there's 1, that would be half in the middle. I'm saying it's about 0.3. Again, you might argue that it's 0.25 or 0.4 as long as it's close to the correct answer. That's what I'm after here. The next part says to find the x value when y is 1.5. So we go to the y-axis now to 1.5 and project across to our line and then down to the x-axis, and we've got to try and guess what we think that x value there is. Now I'm going to guess there's 1, there's 2, so it looks like it's about 1.7 to me. Again, you might have thought it was 1.6 or you might have thought it was 1.65 or 1.75. It doesn't matter as long as you are close. And the final value we need to find for this example here, we need to find the x value when y is 5.5. So we come to the y-axis at 5.5, 5.5, we project across, then we drop down to our x value, and we've got to try and predict what that value there is. Now I'm going to say it's between 7 and 8 there. I think it's about 7.8. Again, you might have thought 7.75 or something close, it doesn't matter. By the way, remember the words that I said before, interpolation and extrapolation. Well, this example here is an example of extrapolation because we're guessing what might have happened beyond or outside the points. But there's our biggest point. We've gone beyond that on the line to predict what might have happened outside my data range, which is between this point and this point. There's my data range there. When I was doing part 3 and I had y equal to 1.5, that was inside the data range, so that was interpolation or interpolating. Righto, let's have a look at our second example now. Our line of best fit has been drawn on. It says, the scatter plot shows a linear relationship between maths marks and science marks in a small class of students. A trend line passes through 30, 20 and 50, 50. And there's 30, 20 there, out 30, up 20. And there's 50, 50 there, out 50, up 50. So they're the 2 points the trend line passes through. Part A says find the equation of the trend line. Well, to find the equation of the trend line, we are given the 2 points in the question that we're going to use to find the equation. So there's no argument about which points to use. They are mentioned here. Now you could use the super formula I talked about earlier, but this could be classified as my first point. So that's the x value and the y value of my first point, so x1 and y1. The x value and y value of my second point, which would make x2 50 and y2 50. I'm going to find the gradient first. Now I know the formula for the gradient is, and remember little m stands for gradient, it's y2 take y1 on x2 take x1. I know what y2 and y1 are. I know what x2 and x1 is. I can put those numbers in. So it becomes 50 take 20 over 50 take 30, which cancels down to 1.5 if I write it as a decimal. Now I'm going to find the equation of the trend line, the equation of the line. This wasn't finding the equation of the line, this was just finding the gradient or the slope of the line. Now I'm going to find the equation of the line using the equation of a line formula, y take y1 equals m, x take x1. If I know m, I found it here, that's the gradient. I know y1, the y value of my first point. I know x1, the x value of my first point. I put those values into my formula and I end up with y minus 20 equals 1.5 bracket x take 30. The next step is to multiply my bracket out. So to do that, I get y take 20 equals 1.5 times x is 1.5x, 1.5 times 30 is 45, and there's a minus there, so that's my expansion. I'm now going to plus 20 to both sides, so what I did was plus 20 to both sides, and I end up with y equals 1.5x minus 25. That is the equation of my trend line. There it is. So we've got the equation of the trend line, we found that. Let's now have a look at part B. It says use your equation to estimate the maths mark if the science mark was 30. Now here's something we need to be aware of. The horizontal axis is my x-axis normally. The vertical axis is normally called the y-axis. That means that when I use my formula here, where I see the letter x, it's talking about the maths mark. Where I see the letter y, it's talking about the science mark. So let's consider x as the maths mark in our formula and y stands for the science mark. And the question says the science mark was 30. If I use this formula, that means if the science mark was 30, I'm going to let y equal 30. So my formula now becomes 30 equals 1.5x take 25 because the science mark or the y value is 30. Okay, let's plus 25 to both sides. That leaves me with 55 equals 1.5x. Now to get x by itself, we're going to divide both sides by 1.5, which means x is equal to 110 over 3, which is 36 2/3 or 36.6 recurring as a decimal. What does that actually mean? What does x stand for? X stands for the maths mark. So using this formula, our prediction is if somebody got 30 on the science test, they probably would have got 36 2/3 on the maths test. That's their estimated maths mark, and that's another way of writing approximately equal to. Let's have a look at part C now. Part C says use your equation to estimate the science mark if the maths mark was 90. Now if the maths mark was 90, and remember the maths mark is x, the science mark is y, that means I'm using x equals 90. So let's use our formula. There's our formula for the line of best fit. X is now 90. So where I see x, I put 90 in its place. I put that into the calculator. It's basically just 1.5 times 90. Take away 25. You end up with 110. So what does that mean? That means according to this model here, if a person got 90 on their maths test, they probably would have got 110 on their science test. Now, if it was a percentage, that doesn't make sense, but that's what we predict based on what everybody else has got. So we are extrapolating here because nobody got as high as 90 on the maths mark. There's a maths mark of 90 out here, and imagine this line continuing through. You look at a maths mark of 90, I'd be coming across, and you'd expect a science mark of 110 according to this answer. So the estimated science mark would be 110. Well, it's now time for you to try some questions. Enjoy the experience. And I'm sure you will, because after all, it's maths, and maths is fun.